Yeah, good evening, everyone. Welcome to today's session. So we'll get started now. Excuse me. So hope everyone can hear me. I'm audible. Am I audible? Okay. So today we'll discuss about recursion, access controls, static members, and then final keyword. Okay, what is that? What are all these things mean? Static and final and access specifiers. Like we have private, public, protected, and default access specifiers. Okay, this is a very, very important topic. Excuse me. Okay, let's get started. So last class we had some revision, so not know that part. Okay, so let us see what are these recursions. Okay, so in Java, a method is called as recursive method. A method is called as recursive method if it calls itself. Okay, if a method calls itself, that method is called as a recursive method. Okay, so the process is called as recursion. Okay, the process is called as recursion. And what is recursion? A method calling itself is called as recursion. Okay, so say for example I have some method 1. Okay, inside this method you call the same method. Okay, this is called as recursion. A method which we have defined calls itself to achieve some goals or to perform some action. Okay, that is what is called as recursion. So what are the conditions for recursion? A recursion must have an if statement. We'll come to that point here. So a recursion must have an if statement to force a method to return without a recursive call. Okay, what exactly happens is you must have an if statement. Through that if statement, you will come out of the recursive nature of a particular method. Okay, so the condition is you must have an if statement. Okay, then where exactly are we using these applications of this particular recursion? We will use it in sorting. Okay, merge sort, quick sort, all those things. Okay, so it makes our what we can say is like it makes code very look very simple. Okay, so that is why we will see a simple example. Okay, so we use it in sorting, searching, signal processing, that is your DSP, and artificial intelligence algorithms. Okay, this is widely used in this and much more other fields also. Okay, let us take a simple example and see where exactly we can use recursion. Okay, we know what is the factorial of a number, right? This is the very common example for recursion. Okay, hold on for a second. Okay, the pen is not working. Give me a few minutes. Okay, this pen is not working. Let me try to see. Okay, so we know what is the factorial of a number, right? So factorial of a number is if n fact, if you want to find out n factorial, we will say like n into n minus 1, n minus 2, up 3 to 1, right? Into 3 to 1. Okay, so how we can achieve, how we can find the factorial of a number using we can use this particular logic, whatever the equation that we have written here, right? So this particular equation we can implement using what is called as recursive method. Okay, what exactly is happening in recursive method? Give me a second, I'm not able to. This go to controls is not working. Okay, so let me explain without that. So what exactly we know this particular equation, right? So to implement that particular equation, we have this method. Okay, public static int factorial. You do not have to use this static. If you use, you can call that method without any this one. Okay, that's why I used it. Otherwise, you have to create an object and then call that particular method, factorial method, object, and then call this method. So to simplify everything, I just used it just like that. Okay, static method. So what exactly is happening if factorial of 1 is 1, right? So as we mentioned, there should be or there must be an if condition, okay, within wherever you are using recursion. Okay, there must be an if condition which will allow us to come out of or which will make the recursive function not to call the recursive function and return it. So what exactly are we doing here? We are returning without calling this recursive function. Okay, so that is, this is the function which is calling itself here. Okay, when n becomes equal, when n is equal to 1, we are returning to the main function which is calling the factorial function. Okay, this is the main method which is calling, we are calling factorial here. Okay, which returns when n is equal to 1, we are returning from this method to the main method. Okay, so there must be an if condition which will return to the caller, of recursive function without executing this particular function, without executing the function itself. Okay, let us see how does this work. So we know what is the equation that we are trying to achieve, right? This is, we are trying to find out the factorial of n. Okay, so let us see when n is equal to 1. When n is equal to 1, what happens? Okay, when n is equal to 1, we will come here, we will pass 1 here, and this will check. Is n is equal to 1? Yeah, return. That is true. So we will return back here, and this will print n is equal to 1. Okay, output is 1. Okay, but when n is equal to 2, what happens? I will pass 2 here, that is while calling this. I'm talking about this particular call. I will call this method by passing n is equal to 2. Okay, this condition fails. N is not equal to 1, so it comes here. Okay, and what it does? 2 multiplied by factorial of n minus 1. That is, what are we doing here? 2 into factorial of 2 star 1. 2 minus 1, which is equal to 2 star 1. Okay, but you observe this particular point. Okay, you observe this particular point. When we are calling this function with n is equal to 1, which again comes here, okay, and checks whether n is equal to 1 or not. When n is equal to 1, which is the case here, it returns. Okay, it returns what does it return? 2 multiplied by 1. 2 into 1, it returns 2 into 1. Okay. Hold on for a second. Okay. So give me a few minutes. Okay. This GoToMeeting control is not responding. Let me log out. Be online. Okay. And log in again to this particular session. Okay. Let me log out and log in again. Okay.